So welcome back to everybody. I think we can start with this last part of the training session of SWAT. So let me share the screen. Okay, first of all, I can do a little recap of what we have seen this morning. So we also answered to the last question about this is step 3, going towards the SWOT editor, and we will see briefly which were the steps that we have taken. So if I open again my my window of SWOT. Okay, actually here now, for some reason I don't have the possibility to click again on this edit inputs and run SWOT plus. That might be because I changed something in the screen, but the way to obtain, in case you also have this problem that you don't see this step 3 available, I will go again on create HRUs and finish restart the process. Okay, this read from previous, as we have seen, we can do this to rerun the same with the same settings as before. I go on read, now on HRU. Here I have the same settings. Okay, let me check the split land use. Okay, it's still, it has the same option that we set before. This morning we have seen this optional setting about splitting agriculture into different sub land use, corn and teff, that is 50% per each. Okay, again, we can save the edits and save the splits, and the same for the extent of land use that we have checked. We said that we want this forest to be among the extension of land uses. Okay, here is the method we have chosen to obtain our final HRUs, the actual HRUs, that is the filter by land use, soil and slope, instead of the others. That's because this one, the one we are using, is the one that lets to, let's say, choose our parameters in a more smooth way, and we can choose different settings between all land use, soil and slope. Like here we have set, in this case, the same numbers, but it would be possible to put a different numbers for each land use. Here we have selected the percent of a landscape unit. We set 10 for land use, go, 10 again for soil, click go, and 10 for slope. And I do the create HRUs. Okay, I can close this tab. Okay, it will be open sometime, but okay, now also step 2 was done, and I also can go back to the step 3. So we saw what we have looked at this morning. If I go back to this step 3, it will open the SWOT editor. Here he's asking me, is my watershed has changed? It says, did you run step 1 or 2 of SWOT since last opening SWOT editor? If so, we'll need to re-import your watershed data. In my case, I have done the rerun, but the setting for the watershed were the same. So we say no, continue to the editor. because we don't want to import a new one. And here we have all the settings that we have decided before. And briefly recapping what we have said, the first part was here in this pencil button about edit, SWAT, and inputs about the weather generator. And for this case, we had to import this data that was made with two small tables, two CSV files, with two files for one for the stations is just a list of the available station, in our case just one, and the monthly values of the precipitation and other data. So we have set these options here, and we have imported the data. And this was about import weather generator data. The next step was the weather station settings. That for this case, we obtained also here from import data, and there was a table that was already in the folder of our example. It was a SWAT 2012 global data website, and from here we had selected let me see, the folder that is this one, Climate Robit, where all the data are stored. So we had selected this, and then again, this is just a directory given to the result, to the place where to put the result. And actually, there was a question before about the rainfall. If we have some records in an Excel format, how to put it in this weather data. Okay, yeah, actually, there is a way to do this, and I can show you some basic about these steps. I will not make an example, but I will just show you how this file have to be treated. So if you have, for example, this data of rainfall has to be put in this weather station setup window. So from here, from the weather station. And when you click on this import data, you will see this is what 2012 format is actually is a format made with many TXT files. So SWAT 2012 means a series of TXT file that is this one in this case. This is for the Robit example that was in the folder Climate Robit. There is this series of TXT files that can actually be created if we have some data in an Excel. That let's say, I mean, these are many data about different parameters like wind, temperature, solar radiation, again another type of wind. But if we just have the data of precipitation and we want to create a file to put in this simulation, the file we will have to look at this PCP, precipitation text, TXT, precipitation TXT, and this following one. This is this ROB, in this case is a Robit PCP, is the specification of precipitation, because we will have to create this one. I will open it. This is one of the two files we will have to create if we have this precipitation. This is just the ID with the name, the latitude, longitude, and elevation. Okay, the ID it can be the name of our station. Or sorry, no, this has to be a number. So in this case, we have the only one, so we can write, for example, just one. And important this name, what to have to be written under this name, that in this case is rob PCP, is the name of the other txt files that contains actually the data of rainfall. So is this one, the rob PCP files that contains the rainfall. So we will have to create more than this simple, just with the name, this one. And this one that has to contain the rainfall data has to be in this format here. Okay, you see there is just, this is just for one station, and it has just one long column, one series of many data. So the file, if you have from an Excel file, has to be copied in a TXT format in this way. It's just a long column, and this is daily precipitation. So for each day, you have to write your to paste the value of precipitation of that day. Okay, here we have some actual values, 2.3, 2.3. And while the other number that has to be on the top of the column, this is the starting date of your for your data. I mean, this means that the data of rainfall is starting from this is January 01. No, sorry, it's the 1st of January. This is January of 1990. That in this case, the rainfall data starts from this date. So this is how it will have to be made, the TXT files with our rainfall. So from if you have it in Excel, you can easily create it also this TXT file, copying and pasting the data in a file like this one. Then, okay, this was about the weather station. Since we are here in the editor, no, okay, I will show you as we did this morning. This was the next step we have set, the run SWAT plus that you see with this triangle on the left, where we simply have to set the place where to write your input files, the folder that will be by default set to this txt in out, and we chose to let it like this. What we changed was the set simulation period, because the data was were going from 1990 to 2013, and from the selection year of the calendar we can change the date of simulation. So we decided to keep it to a smaller to consider a smaller period, a shorter period of just 10 years between 1990 and 2000. Then the other thing to set up is this page about the components, the output to print, that are the main categories of for some for some outputs. They are divided into model components, basic model component, again, some nutrient balance, water balance, plant weather, losses, salts, constituents, and inside of each there are some more actually categories that you will see in the visualization. You will see there are a lot of parameters that can be printed and can be obtained as an output of our model. So here we decided to select the yearly and average data for everyone, for each of the components, and the same for as the monthly. So monthly, yearly, and average for all. And then just for the channel one, we want to select the daily data because it will take time to compute this daily column, but it is useful to obtain some output that we will see in the visualization later. So after doing this, we can click on this save settings and run selected to run the model with the inputs we and checking before that we have tick all of these write input files, run a SWAT, and analyze output for visualization. So after that, and that we have save the setting and run the selected, it will take some minutes to run the model. And at the end, we will have a result like this, where we have this step 4 that's available, where we see this visualize option that we can click on. But one moment before going to the visualization here, I want to stay a little bit here on the SWAT editor to show just which are the parameters and the settings that the model is considering for the calculation, for its simulation, because you actually can select really a lot of parameters. For example, if we go here from the edit SWAT inputs in connections, and we go to channels here, you will see that here we have all the channels in our basin, in our watershed. And for each of these, we can actually select, let me see an example. Okay, if we click here, in this case it's, sorry, I go to channels again. This part for each channel, we can, for example, decide which is the hydrologic and sediment input parameters. So there are these parameters that in this case, they are calculated from our, when we did the delineation of the watershed. So they have been calculated automatically, like the stream order, the width, the depth of the river, the slope, length, and there are some default values for manning, bottom conductivity, erodibility factor, medium sediment size. There are a lot of information, clay percent of bank bed, bulk density, slope, floodplain slope, and many of these information are taken from the DEM, the digital elevation model, and the other input we have put here that were basically the land use and the soil. So all this information were used to compile all of this table. And anyway, it is possible to change manually each of the values. I mean, for this exercise, we will keep these values as default, but just to know that there are really a lot of parameters that we can adjust manually. And this is, for example, that was for a channel. This is a channel. These are some information about nutrients in the channel. These are quite some specific information, but it's that the program already gives as default. So of course we keep it. They are very precise. They are very detailed information of oxygen, algae production, phosphate, nitrogen. There are really a lot of data that, if you know, you could change per each channel, and the same for the HRUs. We can do something similar for the hydrological response unit in case we know we have some information for each specific part. For example, here we are hydrology, in the hydrology settings, where we can set, for example, some many specific information like, for example, sediment concentration in lateral flow, exponential of lateral flow travel time, or soil evaporation compensation factor, some soil water biological mixing efficiency, or again for land use management, there are some tables that have been created, or plant community. Okay, in this case, we don't have many information, but we, depending on the soil map and the land use map, we can have all of these parameters set. The same for the Manning's coefficient for different land areas. If we are in the forest, if heavy forest, medium light forest, it has a different Manning coefficient, a mean Manning or a minimum and maximum Manning coefficient. So we really have a lot of the information that we could put on this model. Anyway, we will keep them as a default, and we will continue from. We can close actually the editor, and we would be able. Okay, let me close it. Okay, for some reason it's opening many times, so I will have to close it. It can happen. This like a bug of the software that might create these things for many openings of some window. Okay, if we go back to our presentation, so after the SWAT editor, the next step would be, let me open the presentation. The visualization. The next step is the visualization of the result, because after running the model, all the outputs have been calculated with the simulation setting as before. And to see them, we have this button here, the new one that's open, that has been opened, that is this visualize, to visualize graphically all of the result. So we move a little bit the slide. Okay, let's open the visualize button here in the step 4. So we click the visualize button, and we have this table, this tab about the visualize result. In this form, the first thing to select is to choose the scenario. We have this pull down menu that shows all the simulation or scenarios that are available. In our case, we have run just one scenario. But yes, another thing that I didn't tell you, that it was that in the editor, if I go back, if I can open the editor also from the window here, SWAT editor. From the editor, it's possible to run different simulation. And this simulation that has been run, they are called scenarios. So in our case, we have just one that is called the default. But if you run another one with other parameters that have been changed in the watershed or in other settings, in other options, you will be able to create other scenarios. But now we will work just on this default one, in the one that we have created. So we have selected it, and then the next step is to choose this SWAT plus output table. And you will see, if I click on this SWAT output table, that there are really a lot of options. A lot of options that can be chosen. Okay, yeah, I was saying a lot of options, and specifically these options, they are described in this way. The first part of the description is for example, this one we have a channel, the first one channel, then we have aquifer, again channel, HRU, LSU, channel, HRU, LSU. They are the units that SWAT is using for our visualization. So if we want a result that has to show a result at the unit of landscape unit, we will have to select one of the landscape unit. If we want some number, some output that is related with a channel, we will have to select one of the channel, and so on. But the other thing to notice about these options is the last part that deals with the time step that we have chosen in the SWAT editor. For example, you see that there is this day option here on the top, that if you remember, it was chosen only for the channel, So you see this day that is related just with some channel settings, while the other are, for example, month, for the first one. Then we have year, Y and R, for almost all the units. And the final one that you see here as AA is, it means annual average. So it's like an annual average calculation for some parameters. And then there is the description inside, for example, in this case, SD or SD morph, or again, SD, LS, NB here, PW. They are the specification of the type of table, the type of data that we are dealing with. So, and luckily, because they are a lot, as it is not possible to learn them all by memory. If we select one, we will see which is a description of what inside each table. For example, in this one, the first one, it says that's daily channel water balance with incoming, outgoing sediment and the nutrient and storage. Or the second one is a daily channel morphology and sediment budget. That is actually the one that has more information about sediment transport and analysis. And then there are other information about, for example, yearly aquifer and the losses. Also here we have some sediment information about the losses in the hydrological response unit. This instead, for example, plant weather, so it's dealing with the precipitation data and the temperature data for hydrological response unit, and so on. So we have many, and these are only the categories, because inside each of these categories there are yet there are a lot of other parameters. So in each of them, and we will see later, there are, I don't know, like 5 to 10, 20 parameters under each of this one. So there are really a lot. So this was for the choosing of an output table. The other part, this part of the tab, that is the choose table, regards the choosing of the time for our output visualization. The one that we are showing that are shown now are the start and finish dates of the output from the scenario we have set in the SWAT. If you see, note that the initial year here is 1993 and not 1990, because we set a warm-up period that was the parameter in the SWAT simulator, the SWAT editor, that if I open, we can check again. It was here in the run SWAT. It was here down in the chose output to print. We set a 3 year of warm-up period. And for this, we don't see the initial year of the rainfall, of the precipitation. So you may choose dates within these if you want to, for example, to shorten the period being visualized, but we will keep them as a first step. Okay. Okay, and again, if you have created other scenarios, the dates will change if necessary to see the whole available period for each scenario. Okay, visualization type. Okay, these 4 tabs. There are 4 possibilities shown by the tabs for static data, animation, animated map, plots, and post-processing. And they show different type of data in a different way. This is static data, these are static maps. They contain a single summary value that is such as like a mean value or a maximum value that is calculated for each aquifer or for each channel, for each HRU or for each landscape unit, and it will be displayed as a map. And we will see it as some example. Again, the animation. In the animation, there will be an animated display of the value, again, of each aquifer, channel, HRU, LSU, at each time step in the animation. So it also gives a map, but an animated map that is changing during time, with the values that you will be changing during the time. Again, the plots, this one supports the creation and display of some graphical plot of some selected variable. And the post-processing will help us to calculate a number of some environmental flows. We will see maybe some example later. For some of them, they can give some nice information. Okay, we can now start with the visualizing the statistic data. Let's start from the first tab. So we have to select the static maps. And about this static map, they are created by generating a shape file. Once you do the print, they will create a shape file. And by default, it will be called with the name of the table that we have to choose from here, and then a result and .shp, and it will be stored in the result directory of the current scenario. So we will have the result. Let me open the folder. There will be a folder. If you have created it in the project in QSWAT plus project as I did, where there is this Robit folder. I had the demo one. And we will have our result under this scenario, default and result. There will be this result folder with all the result of the simulation and actually all of the result of the visualization, because they will appear at this point just when we will create some maps from this visualization tab. So we can start to select one output table, and we want, if we see here from the presentation, we can start with this one, LS, that is called LS unit PW monthly. Let me find it. Okay. It is in this position if you need to find it. And this means this is monthly routing unit plant weather in a monthly time step. So we can click on it. Here we see the shapefile that will be created and its location, its position in the folder. At this point, the pull down menu in choose variables, that is this one, contains all the output variables from your chosen table. So this table already contains a lot of other parameters, you see. When you decide which parameter you want to, which variable you want to select, you will have to select one and then press the add button to add them to the box below. Or there is also this all button to get all of these parameters selected. And then you can also delete. There is this button del to delete if you have selected. If I select, for example, this one, then I press add. Okay, we have this parameter set here. If we then select from here, we can delete the parameter for the box, from the box. Or clear in case if we add more, here we have added all the available variables. We can then for sure clear all these boxes if we don't want them. Okay, let's go to, in this second part, okay, as I said before, for each of the variables or many of the variables, we will have a data that can be daily, monthly, yearly, or an average yearly data of the data. In our case, we will have the daily, as I said before, just for the channel data, because we have selected it on the SWAT editor. But for all the others, we will have both them, either the monthly and yearly data and average yearly data, that is this last one. Okay. Yeah. To display the results, the results we want graphically, we need to produce a single value for each variable, for each subbasin, for example. And for this, we have to choose among this summary the type of data we want, because we can have total means, total data. That means for each subbasin a total value across the simulation. So if we have a period of 10 years of simulation, it will calculate the total of our variable. And again, we can have also the daily, monthly, and the annual means that are average data. That is basically just the total value divided by, and here it depends if we have daily, monthly, or yearly or yearly means. And then we can also have maximum and minimum values of each of the variable during the simulation. So this is how it works, this tab, this window of visualize the result. So we can start to make an example. As we said, we have selected this LS unit PW month, and among the variables, we would like to select biomes. Here I go to choose variables, biomes, the second one. Here there is also a description of the variable. We can see that the unit is in kilogram per hectare, and the description is that it is the average total plant biomass during the time step. So we select the biome, we click on add, and among these choose summary options, we want to select the monthly means. So we want to have monthly values per each month of the simulation. Okay, we can click on create then. Select a variable. Okay, it says me, please select a variable for display, because I have to select these biomes to just do a single click on it. I press on create, I click on create. Okay, we can see now that the shape file is created on the map. We have this new layer that has been created in the subgroup called result. There is this result here in the layers, and we have our default biomes monthly means that we see on the screen. Here we see also in the top part of the map canvas that there is it is displayed the description of this layer. In this case, default average total plant biomass during the time step in kilogram per hectares and monthly data. So we'll also have the descriptions of the layer. What about this? You see that since we have selected let me open it in the table, this LS unit, that means landscape unit, all the data are represented, all this data, at least this variable is represented with a value given to each landscape unit. And as we see, we have in this case different colors for each landscape unit or for each range of values. I mean, in this case, the result layer is given a default coloring using 5 intervals that they cover the range of summary values for the values. Of course, you can change the coloring scheme if you wish. Before this, I want to show you just one thing about QGIS, because you maybe are more used to see the style management, style option of one layer by right-click on a layer, and you click on properties, and from here you will see the symbology. If you do in this way, it is possible to modify the symbols through this step, but it's more difficult, in my opinion, to see immediately the result, because if you change something, you will have then to click on apply, and then OK to see the result that are changing each time. Instead, if we have this window here that I have on the right, this layer styling in the main window open, that if you don't have it here, we have to we can put it by doing a right click in a blank space here in the window of QGIS, and it is this layer styling panel. And you will need to put a tick to take this layer styling panel in order to, okay, here I don't have it, so I click on right click, layer styling panel, and now I have my styling panel here, and this change respect to the one in the property, because when I change something here in these windows, then immediately I will see the visualization that's changing in the window of in the Canva of QGIS. So it's much easier it's much faster, let's say, to modify something. And more than that, we have some other option here that are quite useful if we want to change the styles of a layer. So for this example, we can also, there is this style manager here, the second from the bottom, that if we click on it, we can add different styles to this specific layer. For example, okay, let's select this one. I can click on this add button here and create another style. We can call it new style. It's okay. And for this new style, if I just select it and go to this first button of symbology, we can, for example, instead of this graduated, we can, let's say instead of, we can keep this graduated style because it's the better in these ways, but we can change the color. If we go to this color ramp, change, we can select some other color ramps. Maybe we will like more, I don't know, the blues, this one that, or since we are talking about biomes, about biomass, we can use the green, for example. So if I click the green, okay, here we immediately see the change in the color in the map. And the other nice thing is that if we use this style manager, and if we pass from default to new style, we will see that we have these both styles that we have saved in our map, so we can easily change the color just moving from one style to the other. So if we want, for example, made some different maps with different colors, we can easily pass from one to the other. And this was just a suggestion that I personally like a lot, this kind of layer styling panel with the possibility to play with layer manager and other nice features here. Okay, if I go back to the exercise, let me open the presentation again. Okay, what about then to display then a different variable from the list? Let me open the list. Okay, you just need to select it with the mouse, like another one, and click to create, as we said. And again, it's possible to select another variable and to select another summary. As we like, it depends on the variables that we want to choose. Also, another interesting thing is that if we create from the field calculator, okay, let me go to this layer, for example, this default biomass. Let me open the attribute table, because the attribute table here, okay, here we see this is actually the result of the simulation. So in case you need some result for your for whatever analysis you need, you will need to create this table, this graph, and then from the attribute table you can download, you can or let's say copy the values of these parameters to an Excel file, to whatever, to get your final result. And yeah, another option that was written here, that if you calculate a new field in the field with the field calculator, so if we add a new field to a layer, you will find actually the new field among the variables that can be selected for display. Now, I don't do it, but if I create a new field with the in a layer, then it will appear among the variables here. More than this, there will be the new one that I will just add it. Okay, what about the printing? Because if you see here in the bottom, there is this button print at the bottom of the visualize result, because SWAT provides some templates to create a composition of some images. They can be 1, 2, 3, 4, or 6. Different maps layout, and they can be in landscape or in portrait mode. And SWAT will use the QGIS print composer to support this printing of result. And indeed, you will be able to edit all the templates to change, for example, the text, change the size and position of maps. Each template will include as well the maps and the legends that are, for example, page title. There will be the north arrow, a scale bar, and a text box that contain, for example, author, company, and some date. Now I will show you this thing. First, I want to select some other variables to put in our print composition. So I will go to this choose SWOT output table, and I want the LS unit. Okay, this one that I'm selecting on the presentation, LS unit, LSAA. Let me find it. It's here on the bottom, it's the fourth from the bottom. That is average annual routing unit losses, this case. I click on it. And for the variable, I select okay, let me select the one that's written here, SED or GN. That is this second one. That is, in this case, organic nitrogen transported in surface runoff in kilogram per hectares. I can click on it. I click add. I select it. I create. Okay, we see it uploaded in QGIS. And again, I want to select channel SD morph month. Okay, I select it here, is this one. Channel SD morph month, this one here, the fifth from the top. That is the monthly channel morphology and sediment budget. And from this one, just take an example, we can select this peak R, that is the fourth one, and in this case is average peak runoff rate during the time step in cubic meter per second. I select, I click on add, and I want the maximum. We say here from, let's see from the presentation, maximum to maxima. I go on create. Okay, we will see also that which is the difference now that we have selected some variable from the channel table. Let me remove the others. Okay, you will see that in this case, the result is shown along just the channel. They will consider the width calculated by the SWAT, but we will see the colors that are shown just along the channels and not in the whole area of the watershed, because it's a value. This one is a peak, it's a runoff rate that is typical just of a stream or of channels. So, okay, let me select again. I'll go back to the visualize result. I want to select in the print option here, the portrait as the orientation, and the number of maps. I saw here in little, I selected 3 because I want to show all of our 3 maps. And I click on print. Okay, the print composer started, and okay, let me open it. This is the classical print composer of QGIS that you should have seen in the during also the QGIS training. In zoom. Okay, and actually the maps that will be shown here in they will take the three maps from the result layer, from the result subgroup. That means that so these 3 numbers, the number 3 that we have set here, it will take the first 3 maps from here, regardless of their current visibility. So if we don't have selected this one, if we have some other laser selected, the print composer still will show us our 3 first layers that we want here. And again, another thing is that if we zoom here or here, we see that more than the result layer that we want to show, in this case was the peak of runoff or the default sediment organic and so on. We have, for example, the sub-basin that are shown here in red, because there will be shown as a background the visible layers that are thick in the watershed group. It means okay, if I go to the list of layers here in the QGIS, I should find, okay, I find here the watershed group. In this case, since in the watershed group, we will have this sub-basin that is being selected, and only that. it will be shown with such a transparency. Transparency that is given by each layer style. We will see it in the print window. So that's why you see it here. It will appear both in this map or in the second map or in the third map here. Okay, yeah, all the items in the print composer can be edited. So you can of course change all of the titles. For example, if I want to change the title, just let me zoom a little bit. Just a reminder for QSWAT, for QGIS printing. We can click on each of the feature and modify them. For example, we can just modify what's written here in the title to, for example, SWAT plus exercise. Robit, that is the name of our basin. Then we can change, for example, this image of the north arrow. For example, I like more the one, if I go here if I click on it, SVG image, I can go to these arrows. For example, I usually like more this one, this arrow here, where it's indicated where is the north. And so on. You can modify all the description here of each layer. And then you can export, of course, an image as a PDF or a PNG, whatever type of file. If you want to print, like export as an image, we can create a JPEG image, or from here export as a PDF. We can create a PDF of this image. Another thing that we can modify in this image is, for example, the scale of our representation of our map. So, for example, in this case, I see that it's too small, this image. So I would like to have it bigger. So if I click on it with this select move item pressed, and then I go to this move item content, then if I scroll the mouse, I can move on. I can zoom in. For example, I like, and if I press Ctrl, I move it in a more precise way. Okay, let's say that I like this representation. It's more zoomed. I see better all the parameters. And what we can do now is also moving all the others, all the other maps in the same way, and I have to do it manually. So I will have to change also the other. I will do the same, something similar, and again the same for the third one. Zoom on it. Okay, now we have obtained the same scale. for the image. One thing to notice is that this scale bar here is actually attached at the first image, and at the first image of the print composition. So that if you see, for example, if we again change the scale of sorry, let me go to this. Change the scale of this last one, the scale will not change. But if I change the scale, the position of this first one, press on move item. Okay, you see that the scale, the bar, is changing. So we have to keep attention that the scale, bar in this case, as we see, if we click on it, it's connected with this map. This is called map 2, but is actually if we click on this, okay, we see that this first one is the map 2. So always this scale bar is connected with the first map that we see in the printer, in the print composition. Okay. Again, some rules for creating this print layout. As I said before, if a number n, let's say, of maps are requested, the first n map in the result group of the layers panel are used. So this one, if we write 3, the first 3 maps layers among this result, among the subgroup result, will be shown. If we have here in this layer, for example, 5 maps, 5 layers, just the first 3 will be shown on the print composition if we select 3 images. Again, in the layers in the watershed group that are watershed, let me find it here, are included as a background if they are currently visible. If not, if there is nothing visible here, for example, if I click on this layer subbasins, I remove the tick from here and I go back to the printer. Let me go to the printer. I refresh the view here with this button, refresh view. Actually, I click. Okay, now I should actually recreate from 0 to see this change. But I will not do it now. But if I don't select these subbasins, I will not see the subbasin here. Another thing, if I want to include in one of our map here, for example, a land use map, and I want to create a map of the land use, I have to drag it into the result group before clicking print. So let's do, let's try it, for example, if I want to okay, one thing before, one thing to notice, when you have finished a layout, and maybe you have done a print like as a PDF, let's say we close it. First, remember to save sometime the project. I haven't done in some time, but it's better to do it. Otherwise, I will lose my updating. Okay, let's say that I want to close this printer composition. I close it. And of course, if you want to open it again, you should find it here in the Show Layout Manager. So as we have done in QGIS, where we can create some layout for printing, the same layout created here with this SWAT will appear here in the layout manager. Here are called, in this case, demo 13 portrait. So I can still open it from here, and from here change the parameters and do our print that you want. But the important thing is that once you have finished with a layout and you are okay, it's actually a good idea to delete it from the account manager, from this list of the manager. And that's because QGIS is, let's say, sensitive to have more than one layout created by QSWAT in this manager. So if you will want to print another set of images, it will say there is already a layout here, and so you cannot go on. So we will have actually to remove it after creating a print. So we remove. Okay, I close it. I wanted to show one thing. If I want to add a land use to our print composition, I can take the land use, for example, or better, if I want just to show the HR use, because land use, I would have to clip it in a more nice image, but if I have something, let me see. Okay, if I want to see this actual HRU, I can move it towards the top in this result, under this result. I will put it here. And now if I go to the printing option and I click on, again, I keep these settings. There is print, portrait, number of maps. In this case, yeah, I can select 3. I keep 3 and I click on print. We will actually see the first 3 layers that are under the folder result, under the subgroup result. So in this case, the first one is this actual HR use, that if we zoom, we will see it in the printer. And then the other 2, the second and the third, that will be in this case, this default PCAR maxima and default SED or GN annual means. Okay, this was just to show you how it works with this print composer. I will close it. I will remove it from the layout manager. Remove. Okay. I close the layout manager. I bring back the this layer to where it was. It was together with this full HR use. It was here. Okay, let me see. Yes, I have brought it back here. And another thing that we can okay, let me see this. Another thing that we can do is an animation of some of the result of the SWOT parameters. To do that, we just have to go to the next tab, that is animated maps. And let's say that I want to do an animated tab with the starting from output table the last one we have the selected, so channel SD morph month, that is the monthly channel morphology and sediment budget. So let's click on it. It's already selected. Okay, let me go to the presentation. Selected new in the setup animation group because it's a new image, the one that we are creating. Then one thing is that there are two modes for the animation: the map canvas and the print composer. And we will, for the moment, now use just the map canvas. Then these variables pull-down menu contains all the variables from the chosen output table. And as before, we have all the list of variables. And in this case, I can, for example, choose the flow out, for example. Flow out, it's the third one here, that is the average daily outflow rate during a time step in cubic meter per second. I click on it. Okay, now already with clicking on this variable, we have created a new layer under the subgroup animation here on the top. We have this default flow out. Okay, okay, now we see it better. It's this layer here. And this one shows the initial values for this variable in the simulation. And this range of values actually are all the possible values in the legend run from the minimum and maximum values for the whole simulation period. And yeah, the one you see, sorry, in the maps here are the one at the beginning of the simulation period. While in the legend, you will see all the possible values. But what we can do now to see all the values for all the simulation period here. So let's go to our table. Okay. Yeah, one thing before, if we go to the attribute table of this layer that has been created, I will click attribute table. You will see in the last column, flow out, these values are the values that are referred to the just the first time, the initial period of our simulation. So this is a description just of the, in our case, if you look at here at the description of the period, this is the information about the 1 January, the 1st of January 1993. Okay, let me close it. Okay, this is the result that we are looking at. Maybe I can change the, I can put the LSU as a background to see better the result and the subbasins. Okay, to make the window similar to the presentation. Okay, in the visualize result again here, there are controls to run, pause, and rewind the simulation. It steps through daily, monthly, or annual time steps according to the chosen variables. For example, in our case, we have selected a monthly table, so it will change the value every month. And the speed of the animation can be adjusted with using this speed box here on the bottom. Now it's written 1. And you can also actually change the values manually, change the period manually by dragging the slider here, the mouse from left to right, and we will see always this period, January 1993, the period of when the simulation is showing our result time by time. How does it work, this printing? That the animation is achieved by creating a shapefile. In this case, this is called this default flow out. It is saved in the animation directory within the result directory of the scenario. And at each time step, the values of the variable are updated and the file is redisplayed. So we will see actually that when we will run this recording, the attribute table of the file will change according to the period when we are running the simulation. And they are actually regarded as for this reason as a temporary file, so they are not preserved. And if you wish to save a view of the animation, for example, if you want to save this initial time step that you like to obtain this data, you will have to save it. You will have to double click, right click in the layer, and you will have to, for example, export save feature as, and you can save it in some directory of your laptop as you need. So this is the way to keep one of the result. Okay. 1 second. Okay, the next step. Let me go to the presentation again. If I click on the, for example, on this start button, I will see, and with speed 1, I will see the changing of the layer according to the different period. From, in our case, January 1993 towards the end, January 2000. In this case, at a speed of 1. So it's going quite slowly, but if we want to increase, as we said before, for example, to 5, it will go much faster, and you will see all the layers that have been created time step by each time step. So every month you will have a different value. And as we said, we can also pause the simulation. We can go back at the beginning through these buttons. So, and from this simulation, from this animation, is also possible to make an animated GIF files of the animation. And to do that, let's say that I like the speed of 5. I have to click the green start recording here at the bottom. At the bottom of the screen before starting the animation. And then the red stop recording when it reaches to the end or whenever you want. So if I click start recording, and then I go to this, I start the simulation from here. You will see the simulation going on. And for example, that way that it goes towards the end. When it reaches the end, okay, we have seen all the simulation from the initial year to the last one. I click on stop recording. Okay, it says animated GIF written. I go on OK. And I actually can see now that there is display recording that is available. If I click on it, it will open this animation of our created file, of our in this case flow rate result. So we will change, we will see the flow rate during time, and here at the top part of the screen we will see also the date, the period when this rate is measured. So it's quite a nice feature to see some result from QSWAT. Also, again, one small thing is that the speed of this animated GIF is determined by the value in the speed of this speed here when the stop recording button is pressed. So you may you can also run it at one speed and wait for the finish or for the pause, and then you change the speed before clicking the stop recording according to what you prefer to see as a speed. Okay, one thing to notice that each step of this recording has been saved as a PNG file. But when you stop the recording, the PNG files are assembled into an animated GIF. So the animated GIF is made by saving a PNG file at each step in a folder, in a directory that we have in our Robit results folder. And once these files, once we have stopped the recording, the files are deleted. So to say, if I go back to this, if I click on start recording, I click on the start button, and while it's running, especially if I pause it now at this point, and I go to the folder, to our folder result, I go to the animation, in this case, PNG, I will see that, okay, here there are all the PNG created for this recording until that I have run now. So I can open one of these and we will see each of the image. I can also go right with the right arrow, and I will open all the PNG image. But if I want to export them and to save them, I have to copy it and paste it somewhere, because once I stop the recording here, if I click stop, okay, it has written the video, but at the meantime, we see that the folder that we saw before, PNG, is without anything. So it has removed all the images to create this video. So you have to remember to copy the image before the finish of the recording if you want to save them. Okay, one more thing about this animation mode. If you want to animate more than one variable at once, the map canvas, this one, is not very suitable as the animation will overlay each other. So we can use also here print composition. There is this print composer. Because and actually, even for a single animation, the print composer offers more option to for the setting of the title, author, scale bar, etc. So to do an example, if we keep this new setting here in the setup animation, if I choose, because if I choose current, the next animation will replace the old one. So I click on new. I changed the table here on the top to this one that I have on the presentation, land LS unit, WB, let me find it, month, LS unit, WB month, that is this one, monthly routing unit water balance, and select as a variable, okay, here, sorry, as the variable, this one, surge gen, okay, I will need to find it, surq gen, that's here on the top is the fourth one. That is surface runoff generated from the landscape in millimeter. I select it. Okay, I see actually an animation that is appearing here on the map. The image that has appeared on the map. And I select Print Composer as animation mode, as I did. I select the landscape at the composer option, and the 2 as the number of maps. So it will take the first 2 maps in the animation group. Then I would like to move this slider to the end of the period, just to reduce the number of images. For example, in okay, in this case, one moment. For example, here I wrote, okay, in the presentation I wrote June 2000, but in this case we have the simulation that finished at the 1st of January of 2000, so we can say July 1999. And I click on Start Recording. Okay, a form explain, this form here explains that the composer will start, and you can modify it, but you must then save it as an animation template.qpt. Okay, these are some information that we don't need it at the moment, but we can go on OK. And we see that there is this print composer that opens that is similar to the last one. So also here you can make your modification to the print, to the option. You can modify the title, the scale bar, the north here, the size of the different maps. But we can say that we like it in this way. I go back to my screen of my window of visualize result. Okay, the fact that this red button means that the recording is ready to start. So I can play. I can click on the play on this play arrow, this one. You see the composer used to generate an image for each time step. It can run slowly because it's creating a layout and saving it as a PNG file at each time step. But when it's finished, so now it has finished, I click on stop recording, the red here. Okay, there is this message that tells you where the recording is stored. I click OK. And again, I can click OK to see play, sorry, to see our new animation. Okay, now I've put a velocity that was quite fast, but I can open it again, play, and you will see all the images, all the video that is creating, composing all of these images for these different parameters. And this is similar to the static visualization, where you can change the color scheme or color ramp, number of classes, and so on from this legend. And you can modify everything. The difference between this and the static visualization is that for the static, you have just one print, one map, and with this one we have actually a video of this composition. Okay, I will give you a small overview of the next tab, that is the tab of the plots. We will the last one, that is the post-processing, because it actually gives some information, but is mostly about some statistic data. But this plot one can give some interesting visualization of the result. It can, for example, facilitate some comparison between the, for example, an output of a flow and some observed values that we already have. So how is done the plotting? The plotting is done in two stages. That is let's say, a data collection and a display. And after the collection and before the display, data is saved in a CSV file. And this can be actually loaded also in Excel to also make a graph in another software. But we will see now the representation of the graph here in the SWAT graph visualization. So we are going now to compare a simulated output from our main outlet with some observed data that we have. Okay, I can select from here the variable, the observed data variable that I will take from, it's in the folder SWAT. Again, SWAT plus example dataset Robit observed. We have this observed flow. I click on it. Okay, it has been uploaded here. And what then I can choose, and I want to choose is for the output table to compare to this observed, the one created by the simulation, and the corresponding one is in this channel SD month that I found here. That is the monthly channel water balance. Okay, I have selected it, and from the variable, I selected flow out. I will have to find it, flow out. I see flow in. Flow out is here at the bottom. That is the water out, the one we are comparing. And I decide to compare what is in the final part of the basin, the final flowing, the final flow out of the outlet that goes out from the outlet. So I will have to, okay, first I have to click on add the plot. Okay, so we see our variable flow out, table channel SD month, scenario is default. What is missing is only the unit here. And actually I know that this unit, okay, let me see from here. There are some ways to see which is the unit of a channel in the final outlet. But in this case, I can go, for example, to the. First, I will open the channel file. Okay, so now I can see it. let me, okay, go here. When I select when I go over this all of this number among the selected unit, I see that they are highlighting the channels in the image. So in this case, I actually see that if when I selected this first one, I will see, you see here in yellow, the channel in the final part, that's the one we needed. So then there are here in the presentation other ways, but we will skip these other ways. Okay, I will go on to just make the chart. I have to select the type of chart that I like. In this case, a graph bar chart. I click on it, and then I click on plot. Okay, now it's saying insufficient data for year 2000 for plot 1. Okay, I should have made some error. Let me see if I can modify it. I will have to reduce this start date because for some reason it doesn't see some values for year 2000. Let me go to the, instead of 1 January 2000, to the 31 of December 1999. Let me see if it's working like this. Okay, now it's working. Now it's working. I have to set up this trick. I don't know why it was not working before, but pay attention to this kind of errors that can happen. Okay, I want, for example, to save this. I can save it here where it's proposing to me default result plots. I call it plot. So here we see which is the behavior of the flow out of the outlet. Sorry, outlet during all of these months. But okay, in this case, I forgot to plot also the observed data that we want to see. So I will close it and I will have to click on this add observed, as you see here, so that we have actually also our observed data taken from the CSV. So I want to plot it. I will replace it result plot to this plot. Do you want to substitute this file? Yes. Okay, we still have, I see some problems with some of the period. Okay, let me see what okay, that's because this observed file is missing for that. So we would actually like to change again this finish date to December 1997 in this case. We try again, plot, default result, again plot, I try again, substitute the file, yes. Okay, so finally we have our result. And so this is the plot where we see the comparison between the flow of our model, that is the blue one that we see in the graph, and the green one that is the observed one. The peak has been really, I mean, has been at at least the period has been taken into account well. There are some peaks, for example, this first one, where actually the simulated one is not really well described respect to the third one, and the second one where the second peak where the observed one, that is the green, is quite higher than the simulated one. We can also see it from some coefficient that is shown here on the map about correlation. In this case, Pearson correlation, we have 0.71. And this one, Nash coefficient of 0.36. That's quite low actually. But this was just to represent an example of this. For this graph, we can actually do some other kind of type of plot, for example, a plot load duration curve, or we can make a scatter plot. Okay, maybe for this type of data is not very, it doesn't have a real meaning, but it's just to show how the plot appeared, or a box plot. We can have this kind of a plot that can be interesting. It depends on the variable you want to show. So before finishing, just let me show you more about, since there are, this is what model is used to calculate, to have information about the sediment transport and in general the sediment behavior in our catchment, in our basin. We can see some example of some sediment data that we can get from our result. For example, the main one, I would say, okay, let me, okay, we can keep this period. If I go to static map, I choose, for example, channel, no, sorry, I will go to at the LSU unit level that will show the sediment along all the basin. Okay, should be this one, LS unit LS yearly routing losses. If I click, for example, in this one, and as a variable, I select this one, here we have actually a sediment yield in tons per hectare, for example. And the description would be sediment yield leaving the landscape caused by water erosion. So if I open on it, I want, let's say, the monthly means, or no, annual means. So we say, I open it, add, create. Okay, let me see. Here we have these values. Let me close it just to show you one of the results about sediment transport that can be seen. Here we see now in our watershed. Here we can see the sediment yield that is leaving the landscape at the different places caused by water erosion. Okay, now everything is green here, but I will have to change a little bit the legend. 2 seconds. If I go to graduated, for example, let me modify it fast. I want to sediment yield, color ramp, for example, in reds. I go to classify. Okay, for example, yeah, for this case, we have this sediment yield in the basin. So we see also with the colors, but also with where with actual numbers, the tons per hectare in each part of the basin that can go. It's that is transported, is eroded by water. So this is one of the sediment quantities and analysis that can be done with SWAT. And the same thing, similar, can be done with, for example, in the layer, in the table channel ST-morph day. It's like a sediment budget. Okay, if it's working. Yeah, for example, through this one, we can see about sediment. For example, this sediment out, let's say, add it. Also, yeah, I can go to annual means. I can go to create, and we will say the sediment. Let me remove this. Sediment that goes out of each channel in annual means for the different channels instead of along an area of the subbasin. So we have quite a number of these options to understand the behavior of the soil, of the erosion, of the transportation of soil materials, and so on. So yeah, I think yeah, we can conclude here. Yeah, this presentation. If you want to ask anything or do you have any question before to leave? Please feel free to ask. Okay, so in general, you have seen that there are many possible options to set, let's say, in this in a SWOT model. The most difficult thing I would say is just to understand that at the beginning, to have at first an idea of how is working the model. But once, for example, if you try to do this exercise later following the presentation or the recording, and step by step, you will be able to do this again, and you can become more familiar with the program, and you will see that there are many options that you can decide, many settings, and many results that you can obtain. So this is what I gave you an overview of the main features, and but with this one you actually would be able to use a huge part of this software. So I think, Muna, we can conclude the training if I don't see any question, and thank you very much for your attention, for participating to this training. Do you want to say something?
Yes, Giacomo. As you said, today was much easier than yesterday, I think, because in the first day it was very informative. Many informations, but now after we go step by step, it becomes more clear. and it is very, very interesting tool. As in the Nile Basin, sediment is very a critical issue. I think it is very important tool. Thank you, Jakim. From my side, I was very happy to join all these steps and practice it. And I hope all the participants like me. Thank you. And by this, we conclude the training session of the SWAT. Thank you all participants. Thank you Hydronova, and see you in the last session next week of HECRISM. And next session will split into 2 successive weeks, 1 day per week. I mean, next week will be first training session, day 1. I mean day 1, and the other week will be, or the next week will be day 2. So until that, thank you for your attention and for your attending. Thank you, and we will meet next week, inshallah. Goodbye now.
Thank you. Goodbye, all.
Goodbye. Goodbye.
Goodbye.
Bye. Bye.
Thank you very much. Thank you.
Thank you. Thank you. Thank you.